Hi, welcome back to Leetcode. Today I'm going to discuss Leetcode problem 1963. Minimum number of swipes to make the string balanced. So you are given a zero index string S of even length, n. The string consists of exactly n by 2 opening brackets and n by 2 number of closing brackets. A string is balanced if and only if the string is empty, then it will be balanced. Otherwise it can be written as AB, where A and B both are balanced strings, or it can be written as opening bracket, closing bracket, then in between C. So C is balanced already. Okay, now you may swipe the brackets at any two indices any number of times. Return the minimum number of swipes to make S balanced. So we'll be given a string is, suppose for this example here actually closing bracket, opening bracket, closing bracket, then opening bracket. Here actually what is the n is 4. So number of opening bracket will be 2, number of closing bracket it will be 2, n by 2. Now is this input string is balanced? No. Balanced means here actually you can check, we are getting a closing bracket but there is no opening bracket before that, so it is not balanced. So if I want to make this as balanced, then how many actually swipes, minimum number of swipes we need? So first we will have to find that how many actually position actually not balanced. That actually, if that actually balanced, then automatically whole string will be balanced. If we balance the disbalance actually strings position, if we match that, swipe and correct that, that will actually balance the whole string. So here actually this is not balanced and this is not balanced. You can check this actually the balanced already. Now if I swipe this 2, okay, then what will be the string look like? String will look like opening bracket, this already there, and this will be closing. Now it is actually balanced. So how many operation we did? Only one operation. So here answer is that's 1. Okay, you can actually maximum in infinite time actually you can actually do the operation swipe, but they ask for asking for minimum number of swipes. So here actually you can check only by using one swipe you can actually make this. Now go to the next example. Example 2. All are actually all 3 are closing, then opening. Okay, here actually how many actually position are actually displaced? 3 position, because here actually we should get a opening bracket, there is no opening bracket. Here also same, here also same. Okay, similarly for this case also same, like here actually we are expecting opening bracket, after iterating the string we are not getting any closing bracket. So that's why this actually 3 actually closing bracket we are actually getting and 3 opening bracket. This actually both are actually displaced. Whatever here actually the same, one closing bracket we are getting displaced, similarly one opening bracket is also getting displaced, right? Now you can check closing bracket and opening bracket both are actually number is similar, same, should be same, that will be swapped and that will be matched, right? That's why both should be same. What about the actually number of actually closing bracket displays, and similarly for the opening bracket. Now what is the minimum number of swipe needed to balance this input string? You can check, if I swipe this string, these 2 position, then how does the string look like? This is opening, then this is already closing, this is already closing, this is opening, and now this is closing, right? Now how many actually how many actually position are that is disbalanced? This is already balanced, this is already balanced, only these 2 position are there, one opening and one closing, right? So if I just swipe this, so what is the string look like after that? Opening, closing, then opening, closing, right? So this actually balanced, this string is balanced. You can check whenever the getting opening bracket you are getting closing bracket, similarly for the all of the position, correct? So how many actual operation we did? 2 operation, so that's why answer is 2. But now let's take some observation. Let's see some observation here. First of all, the string is only this. How many actually what are the number of opening bracket? One opening bracket, one closing bracket, that are displaced. How many operation we did? We need 1. So here answer is 1. So just make a chart actually, number of disbalance bracket and answer. Here actually number of disbalance is 1, because whatever the opening bracket and closing bracket is short, we are counting only 1. Answer is 1. Okay, now go to the next example. Suppose twice, 2 position actually disbalance. How many operation we need? We need only, if we swipe this, okay, then what does string look like? This is already balanced, so for number of disbalances 2, the answer is still 1. Correct. Now go to the next, where the number of disbalances is 3. This is 3. Okay, now how many operation we need? If we swipe this, then string will look like this, closing bracket. Now still one position is there, so we have to swipe this again. So the string ultimately it will be this. So here actually now it is actually balanced. Now for 3 disbalance also, the answer is 2. Number of two operations needed. Similarly for 4th. Okay, now what to do? Just swipe this. String will look like this, closing, opening bracket. This is now it is closing bracket. Now if I just swipe this 2, so string will look like this is opening, closing. Now it is balanced. So how many operations we did here actually? 2. Okay, you can check. Now for 1 also your operation we need actually 1. 2 also we need 1. 3 also we need 2. 4 also we need 2. Okay, so first of all, it is sure that whatever the number of disbalance actually we have, x, suppose x number of actually bracket not matched, opening or closing, both should be there. So we need actually x by 2 number of actually operation. Now here you can check if there is only one disbalance bracket. So how many operation, if I just divide this, it will be actually 0. But if I take the floor of ceiling, then the answer will be 1. Correct. So that's why you can do one thing, you can check also, just do 2, like you can check, suppose 1 plus 1 by 2, this also give 1, and 2 plus 1 by 2, this also give actually 1. Correct. They actually give the actual output, like by 2 is actually guarantee that whatever the number of disbalance bracket are there, we need actually half operation. But to handle this, like for one disbalance bracket, we need actually 1 operation. So that's why we are just adding 1 plus 1 by 2, we are getting 1. Similarly for 2 disbalance, we need actually 1 operation only. Here also we need 1 operation. So that's why 2 plus 1 by 2, we are getting 1. Now 3 plus 1 by 2, we are getting 2. We will check 2 operation. Now 4 plus 1 by 2, you are getting 2. Correct. So first of all, it is logically it is clear, right? If you have any doubt, you can please comment on that. And if you have liked the explanation, it is clear, then please like the video. Okay. Now what is actually steps? Steps is first find out number of disbalanced positions, right? Count number of disbalanced positions. Now we need actually whatever the actually in the count, x plus 1 by 2. This will give the minimum number of swipes we need. Correct. Observation is clear. Why you need x plus 1 by 2? Right. You can also take the actually ceiling also, whatever the x by 2. How ceiling will work? Suppose this actually operation is 1 by 2, ceiling will give what? 1. 2 by 2, ceiling will give 1. Correct. Then ceiling of 3 by 2, it will give 2. Similarly for 4 by 2, it will give 2. Correct. It is clear. ceiling also will work similarly. Ceiling also work in this way, x plus 1 by 2, whatever the value. Okay, now how actually we can find the number of displaced position? Now we can, what actually we expect whenever getting a closing bracket, we expect that there is one opening bracket at before of this position, right? So you can take like here actually both the same number of displaced closing bracket and opening bracket, both are count will be same, because that will be actually matched ultimately. If it is not matched, not balanced, now ultimately whatever, like here actually you can check, suppose this, okay. Now you are storing whenever getting a opening bracket, closing bracket, we expecting that there should be any opening bracket, but there is no opening bracket. We will actually go to the next character. Next character is again closing bracket. There is no opening bracket I have seen till now. So go to the next again, closing bracket now again, but there is no opening bracket I have seen till now. Go to the next closing opening bracket. So I am storing this here. Okay. Now go to the again opening bracket. Yes, opening bracket. Now go to the again. This is opening bracket again. Okay. Now you can check ultimately how many actually displays actually still in this stack. That actually the number of displays position of opening bracket. And similarly, the count will be same. Correct. You can check. You can also count the actual number of displays. Like whenever we are getting closing bracket, and if there is no opening bracket present till I have not seen before that, then increase the count. You can do that. Both are same. Here actually I have solved this problem by using the count of opening bracket. You can also solve this by opening number of closing bracket also. Okay. So I'll take a stack. So I'll just pull, whenever you're getting opening bracket, we'll push this into the stack. Else whenever you're getting the closing bracket, I expecting that there is an opening bracket. It should be, if it is there, if it is present in the stack, I will just pop that because it is matched, because it can be present, right? In this way. This is so first of all I will actually, for this position there is no opening bracket, go to the next. So this is opening bracket, I will store this. Again go to the next, this is a closing bracket, we are expecting opening bracket, yes there is a opening bracket present, so I'll pop this because this actually matched, balanced. This substring is already present, balanced. Now go to the next is again opening, so I'll store this. Okay. Now you can say after iterating the whole input string, our stack size is still 1, so that means one position is not balanced, so that would be balanced. Got it? Now go to the code display. Now code, I'll take a stack for actually storing the opening bracket only. Okay. Now iterating the input string s, if it is opening bracket, I'll store the current character into the stack, right? Else if what, my current character is closing bracket. So if our stack is not empty, then I will pop that. That means this is balanced. This is, we are getting this kind of actually situation. First of all, store this into a stack, and now we are getting this. This is my current character. I am checking that my stack is not empty. That then just pop this. Okay, correct, and return. And after iterating each whole string, I'll check what is the stack size. Okay, stack size means number of displays by opening number of displays position by using the, I have used here actually opening bracket. You can also use the logic to count the closing bracket also. Correct. Now what do you have to return? Whatever the actually number of display position, x plus 1 by 2. Also I can return here actually ceiling of st dot size by 2. Okay, 2.0, because otherwise it will take the integer value. Correct. So if it is decimal, then it will check the next integer. Correct, it is clear. Now what is time velocity of this? Time velocity, we are iterating, suppose our string is length is L, so we are iterating each character here, so that's the time velocity will be big of L. Now space velocity, we are not doing anything extra, so that's the space velocity big of L. Space velocity will be similarly, suppose L by 2 maximum L by 2, because whatever the length of the input string, there should be maximum L by 2 actually opening bracket, and that can be stored suppose in this way, this. So all are actually their length is 6, so how many actually opening bracket are maximum? 3, n by 2. So if I store this here actually not, and that is all are actually disbalance position, so I will store these all three opening bracket into a stack. So our stack size maximum goes up to L by 2. So that's why the space count is big of L by 2. It is clear? If it is clear, and if you like the explanation, please like the video. And if any doubt, any suggestion, you can comment on that. And if you not yet subscribe the channel, please subscribe the channel. And you can share also with your friends. Thank you.